Hello, algebra students. We're going to talk about section 9.1, solving systems of linear equations by graphing. We're going to start by graphing a couple of inequalities, which we've been practicing. And we're going to start with x is less than 2. So we go over to our graph, and we know that an x equal to line is a vertical line. So x less than 2 is going to be a vertical line at 2. Now, because it's less than 2, the 2 is not included, so we're going to have a dotted line. And we want to mark where the values would be less than that, and since it's an x less than, what we're looking at are x values, or the part of the graph where the x values are less. And so that is going to be to the left-hand side. So we'll be shading over here on the left, and of course continuing over. Then we would graph our other inequality, but before we graph the other inequality, we want to put it into slope-intercept form. And so under that inequality, we would add 2x to both sides. And that's going to give us y is less than or equal to 2x plus 3. And that's going to tell us how to graph that. So we have a y-intercept at 3. And then our slope is 2. So that's going to be up 2 and over 1. And so, of course, that is going to give us our line. And it's an equal to or equal to, so that is a solid line. And because it's less than or equal to, we want to graph where the y is lower than that. So we would graph the portions below. And so what we're looking at is this intersection space in here. And so this space in here would contain all of the solutions that work for both inequalities. So if we're looking for, what is a system of equations, it's going to be two or more related equations for which you're looking for a common solution. So again, that's two or more related equations, and you're looking for a common solution. So the solution makes both or all of the equations true. So starting with example 1, we solved the system by graphing, and we have two equations here, 2x minus y equals 8 and x plus y equals 1, and we want the solution to them both, the solution that they have in common. So in order to do that, we want to graph them, which means we want to get y alone. Now this should be something you're familiar with in order to graph. So we'll start with 2x minus y is equal to 8. And in order to graph that, I want to put it into slope-intercept form. So I'm going to subtract 2x from both sides. That gives me the opposite of y is equal to negative 2x plus 8. Now, of course, in order to get that y by itself, I've got to divide everything by negative 1. And so that gives me y is equal to 2x plus a negative 8. And then I can go over to the graph and graph that equation. my y-intercept is at -8, and my slope is 2, so that's going to be up 2 over 1, and that is going to create that equation. And then I want to solve the second equation. So I have x plus y is equal to 1. And again, I want to get that into slope-intercept form. So I'm going to subtract x from both sides. And that's going to leave me y is equal to -1x plus 1. So again, then I can graph. So I'm going to go over to my graph. And my y-intercept is at 1. And my slope is -1, so that's down 1 over 1. And that creates this line. So then once we have them both graphed, we want to look at their intersection point. And we have their intersection point here, and that is the ordered pair 3, -2. And so we're going to insert that there. And then, of course, graphing sometimes is not the most accurate. You do want to make sure to use a straight edge. I've caught that I corrected my first line there, which was a little bit off. And so when you're solving by graphing, you do always want to check your solution, and you want to check that that ordered pair makes both equations true. So I'm going to go back to my original equations, and I'm going to plug in the ordered pair 3, -2. And you can see for that first equation, that makes that true, so that's good. And then we would look at the second equation and make sure it's true for that as well. And we get another true statement, so we know that our 3, -2 is the solution to that system of equation. It's the solution to both of them. So we're just going to practice that, and we've got two new equations, 2x plus y equals 2 and x minus y equals 4, and we want to solve that system by graphing. So we need to graph them. In order to do that, we want to put the equations into slope-intercept form. So starting with the first equation, again, I want to solve for y. And that gives me y is equal to -2x plus 2. So I can go over to my graph, and my y-intercept is at 2. And the slope being -2 is going to be down 2 over 1. And so we would get a line intersecting those points. And then we're going to graph our second equation. And in order to do that, again, we want slope-intercept form. So I'm going to solve for y. So subtracting x from both sides, we've got -y is equal to -1x plus 4, but we've got to divide everything by -1. And y is equal to 1x plus -4. And then back to the graph. So we're going to plot the y-intercept, which you should know is at -4. And then the slope being 1 just means up 1 over 1. And so we've got that line. And hopefully you spotted our intersection point. And that intersection point is 2, -2. Now we do want to check that that solution is in fact making both equations true. So we'll start with our first equation again. And we plug in 2, -2. And we get 2 equals 2, so that makes that statement true. And then to our second equation, which was x minus y equal to 4. Notice I'm going back to the original equations. I want to do that because I could have made a mistake anywhere along the way. And so if I'm getting a check that doesn't work, I want to know that there's a mistake there, and I want to be able to catch that mistake. And I get 4 equals 4, and so another true statement. So I have found that 2, -2 is the solution to that system. So we're going to start the same way for our next example. So we have our first equation, x minus 3y is equal to 2. Solving for y so that we can plot in slope-intercept form. This time we have to divide everything by -3. And I hope you're becoming comfortable with solving for slope-intercept form. If you are not, you do want to see your algebra teacher during REM or an after-school study session. We get for this slope-intercept form y is equal to 1/3 x plus -2/3. Excuse me. So then we want to graph that. Now our y-intercept is at -2/3 on this one, so a little harder to graph that, but that just means we're going down about 2/3 of the way to 1, and our slope is down 1/3, so down 1/3 would put that line, oh, I'm sorry, it's up 1/3, up 1/3, so putting that line right there. And that gives us that line. And then we have our second equation. And that second equation we want to put into slope-intercept form. So we're going to start with 3y minus 1 is equal to x. Here we have to add 1 to both sides. We've got that 3y is equal to x plus 1. And now we're dividing by 3. And y is equal to 1/3 x plus 1/3. And so our y-intercept for this one is at 1/3. So that is going to be 1/3 of the way up to 1. And our slope, again, is up 1/3. So up 1/3. And this is our results. Now, as you can see, we don't really have an intersection point that's visible, and that is actually correct for this because we have the same slope, and the same slope means that the lines are parallel and they should never meet. And so the solution to this system is the empty set. Now the only exception to that would be if the y-intercept would be the same, then you actually have the same equation. But here, same slope, different y-intercepts, that's the empty set. There's going to be no intersection, so there is no solution. So we've got another example here. Again, we want to put it into slope-intercept form. And we get y is equal to 2x plus -1, so I can go ahead and graph that. Our y-intercept is at -1, and our slope is 2, so up 2/1. And that gives us that line right there. And then we would go to our next equation. So I'd like you to solve that next equation for slope-intercept form. And you should notice that we get y is equal to 2x plus negative 1 again. These are the same. If I would go to graph that, I'm going to graph the same line, which means I'd be going over absolutely every point. So when it is the same, that is, it's not all reals because it's not all real numbers that would solve the line, but it is that line. Like every single point that qualifies for that line also qualifies for the other line. So it's another kind of solution. So just in order to summarize here in conclusion, in order to solve a system of linear equations in two variables, you need to draw the graph of each linear equation in the same coordinate plane, and you see where it intersects. Now that gives us three possible solutions. If the lines cross or intersect, there is only one solution, and that's going to be an ordered pair that you check, and it makes both equations true. If the lines are parallel, then they have the same slope, and there is no solution. If the linear equations coincide, in other words, they are the same equation, then there are infinitely many solutions. Because it would be every point on the line. Please remember to take any questions into your algebra teacher.